Okay, so now we got to figure out what's going on, right? We want to be able to figure out, what's going on, if something is going faster or slower, okay? So we got to figure this out. All right, here we go. So again, if we only know the acceleration, doesn't help. We don't know. So we got to find out, we got to know something besides acceleration, okay? So here we go. All right, so describe the motion. Well, all right, so the velocity is positive because it's going to the right, and we said right was positive. So the velocity is positive, and we know the speed is increasing. Agree? All right, so the velocity is positive because it's going to the right, and we know that the speed is increasing. All right, now, what is the direction or the sign of A average? Now, how are you going to do this? You're going to philosophize? No, you're going to do the vector subtraction, right? Vector subtraction. Okay, so let's do the vector subtraction. Well, you do it, all right? So pause your video and you do it. You do it. Okay, so we're back. All right, so we want, again, we want, so V final minus V initial equals V final plus negative V initial. Okay, so V final is this way, and then V initial is that way. I'm just put it underneath it, minus V initial, right? And then you go from the beginning to the end, and you go like this. So that's delta V. Okay. So what is the direction of A? Well, the direction of A is the direction of delta V. It's to the right, so it's positive, right? So this is A average, okay? So A is positive, all right? All right, so what do you notice? If the velocity and the acceleration have the same sign, right? They're both positive here. We have increasing speed, all right? Same sign, increasing speed. Let's do another one. Describe the motion, okay? The velocity is positive. And what's happening to the speed? It's decreasing. So velocity is positive, it's decreasing, right? It's going slower because this is obviously less than that, all right? Okay, find the sign, which means the direction of A. So you do it. Please pause your video and do it. All right, let's do it together. So here we have this again. So V final is this thing. And then minus V initial is pushed to the left. So head to tail, exaggerated, whatever, minus V initial. So we go from the beginning to the end, and there it is. That's delta V. That's delta V, all right? So what's the sign of the acceleration? Negative, all right? So what do you notice? If the velocity and the acceleration have opposite sign, the thing slows down. So that's it, all right? So let's review it. Okay, so here they have the same sign, right? They're both negative. So what do we learn? If they have the same sign, what's true about the speed? Increasing, all right? Increasing. If they have same sign, increasing or decreasing speed? Increasing. So notice, I don't care if they're both negative or if they're both positive. The important thing is they have the same sign. Both negative, both positive. Increasing speed. On the other hand, here they have opposite sign, right? One's positive, one's negative. What kind of speed? Decreasing. All right, that's how it is, okay? So you're going to use this the whole semester, all right? So you want to remember it, right? Same sign, increasing, opposite sign, decreasing, okay? So basically, what have we seen, So it's not enough to know the acceleration. You have to know the acceleration and the velocity to be able to determine if the speed is increasing or decreasing. You need two pieces of information. Okay, so read that, and pause your video and figure it out. Okay, let's do it. So again, what do you have to know? You have to know A and you have to know V. Okay? Let's see, the thing is moving to the left. So that means V is negative. Right? So V is negative. And now we have to know A. The direction or the sign, right? We're going to just use that. So V final minus V initial equals V final plus negative V initial. Okay, so V final is this. And then minus V initial is like that, head to tail. So there's minus V initial. And so you go from the beginning to the end. Here's the beginning, here's the end. So that is delta V. Correct? So what's the sign of delta V? Delta V is pointing to the left, so it's negative. So A is negative, right? Because the sign of delta V is the sign of A. So A is negative. So we have V negative and A negative. So what's going on? The speed is increasing. Okay? Well, come on. We already knew that. Did we have to go through all this mumbo jumbo? You didn't have to do all that. I mean, it's obvious, right? Here, you know, this is not very long. Here it's longer. So we know the speed is increasing, right? But it's nice to be able to analyze it this way, okay? So what are the signs of V and A? So V is negative and A is negative, okay? So if they're both the same sign, we know the speed is increasing. Okay, there you go. Don't forget that. Don't forget that. All right, okay. So I confess I forgot to bring something. But that's all right, I can describe it. So this is a cart, has a fan on it. That's called a fan cart, all right? So what you do, you know, you get the fan going, and then you push it, right? And then it comes back, okay? So like I said, you push it away, and then it slows down, then it stops, and it turns around and comes back, all right? Faster, faster. So what I want you to do is I want you to draw the motion diagram for both directions. So this way, when it's going slower and it stops, and then this way when it's going faster, faster, faster. So pause your video, please, and draw the motion diagram for this thing. All right, let's see what you come up with. Hopefully something like that, right? So here, you know, it's going slower, 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 then it stops, and then faster, 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 right? So these vectors represent the velocity, right? Magnitude and the direction, you know? Okay, great. Now, any questions? And we call this, and this is where we started, right? So I'd call that like x equals 0. And this is x equals x max, right? It's the maximum x, the furthest distance away, x max. All right, so let's think about that. Oh, I think I just gave this away, right? For the fan cart, what is the velocity at x equals x max? Well, I did just tell you this. So what is it? It's 0, right? It stopped, right? It was going this way, slower, 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 then it stopped, then it turned around. Went faster, faster, faster. So the velocity at x equals x max is 0, all right? 0. It's just like this, you know, if you shoot something, throw something up, you know, what's the velocity at y max? 0, right? It stops. Slower, 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 stops, then faster, 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 you know? Same thing. Okay. All right, now here's the tricky one. For the fan cart, what is A at x equals x max? Now, the philosophers in the room who don't analyze, they would say it's 0 because they don't understand physics and they refuse to think. Don't do that, all right? Analyze. Use the laws of physics. Use what you learn in physics. Okay, so how do you figure out what A is? Well, you know, the direction of A is the direction of delta V, which is the direction of V final minus V initial, right? Okay, well, what's v final and what's v initial? Okay, we're trying to get the acceleration here. Well, then what's v final? It's kind of like v after. What's v initial? It's like v before, okay? So I could have written that too, you know? I could have said the direction of v after minus v before. All right? So obviously, this is v before, and this is v after. So please use that, do the vector subtraction, and figure out the answer. So please do this now. So pause your video. Okay, I assume you've got the answer, I hope. Let's do it. Let's do it before we look at it. All right. So, okay, so v after is v4, right? So that's like this. That's v after. And then we want to subtract v3. So v3 is this way. So that means minus v3 is this way. So we want to add that. So there's v after. Then we add v3, which is v initial. So that's v before, or v initial. So when you add that, you get this, right? Right? So there's your A. Okay? So, oh, yeah. So this is the cover sheet of an exam, right? Physics 121, fall 2015, long time ago. So I have these instructions, right? So I always write this: analyze, don't philosophize. All right? Anyway. Okay, so look at, when we analyzed it, what did we figure out? A is negative. A is negative. Again, the philosophers would say 0 because they don't understand and they don't analyze. Don't do that. All right, let's see. All right, very good. Okay. All right, so now read this and answer it, please. So pause your video and figure it out. All right, I assume you've paused your video and done it. So you're throwing a ball straight up in the air at the highest point. All right, let's analyze it, right? So at the highest point, what is the velocity? Well, 0, it stops. Okay, so the velocity is 0, no kidding. Okay, but now we got to get the acceleration. All right, well, this is what it looks like, right? So, you know, it's slowing down, and it stops, and it turns around, right? Okay, so this is I would say, I call that v before, or v initial. I call this guy v after, or v final, right? So this is the v before, and this is the v after. All right. So let's do it. Okay, so v after is like this. I'll make it a little longer. All right, so there's v after. And then we want to remember how you do this. So v after plus a negative v before, right? That's how you subtract vectors. Okay, so there's our v after, or v final, whatever you want to call it. And then, okay, v before is like that, right? But we want negative v before, so it's like that. All right, so there's minus v before, or minus v initial, whatever you want to call it. So if you add those two, you get this, right? So there's your A. All right. So the velocity is 0, but the acceleration is certainly not equal to 0. Right? Certainly not equal to 0. Here's another way to look at this. I mean, I'm kind of jumping ahead, I admit. So what's the most important equation in all of classical physics? F equals ma, right? All right. So if you throw something up, you know, what's the force acting on it? Because we're ignoring air resistance. It's the force of gravity. Well, if A were 0 at the top, that would mean that the force of gravity is 0, which is ridiculous, right? Does the force of gravity all of a sudden stop when this thing reaches the top? Of course not. Okay? So anyway. Very, very important. By the way, this is called a turning point. Turning point. And that kind of makes sense, right? Because, you know, the direction is turning, right? It's changing. Just like This is called a turning point, right? So we would say at x equals x max, it's a turning point, because at a turning point, the velocity is 0, and the object changes its direction. So the acceleration is not equal to 0. So turning point, we'll use that a lot. Turning point. All right. Let's see. Oh, wow, there it is. Isn't that a great picture? All right, turning point. Okay, so at y equals y max, velocity is 0, but a is not 0, right? A points down, in fact. So turning point. All right. All right, we're doing great. All right, so this is just like a review, right? So you got to know these like the back of your hand. This is like basic stuff. Learn how to crawl. Displacement, change in position, r final minus r initial. Average velocity, delta r over delta t. So there's this vector subtraction there, right? Average acceleration, delta v over delta t. So this is a vector subtraction. So you see what I mean? We're always doing vector subtractions. They're super important. Oh, yeah, we said this already, right? If the object's speed is increasing, a and b have to have the same sign. If the speed is decreasing, a and b have to have the opposite sign. That's all there is to it. And the direction of a is the direction of delta v, which is the direction of v final minus v initial. Yeah, and that's a turning point. Okay, let's talk about graphs. We use graphs a lot in physics because they represent data. And it's a nice, easy way to see what's going on in a situation. We also use graphs a lot in lab. So if you're taking lab, which I hope you are, we're going to use graphs all the time, you know, because they're super important. So this is called a x versus t graph, or if you want to call it distance versus time, right? Or you can call it a position graph, whatever you want to call it, you know. Okay, one-dimensional motion, that's all we're doing, one-dimensional motion. All right? And again, you know, one-dimensional motion, this is the positive direction, that's the negative direction. That's just kind of like a decision we made, you know. All right, just keep it simple. And this is the origin, right? That's the origin. Okay, so let's describe the motion. So, you know, here, what's going on here? Okay, what's going on here? Well, let's see. So, this is a straight line. What's the slope? What's the slope of this line? So remember, from when you took algebra or something like that, slope is the like delta y over delta x, or you can say it's the rise over the run, right? Okay, so what's delta x, or what's the rise? It's x in meters, right? So it's delta x. It's a change in position, and it's in meters. What's the run? It's the change in time. Minutes, it's supposed to be seconds. Who cares? Let's just say seconds. So it's delta t in seconds. Well, what's delta x over delta t? It's the average velocity, right? So it's velocity in meters per second, right? Okay. So here the slope is constant, okay? So that means that the object has the same speed in the same direction. Now here the slope has decreased, so the object is slowed down, but again, you know, same speed and same direction over this line. And then what happens here? It's a faster velocity, right? Okay? So, you know, we could actually figure it out if we had a calculator, which, you know, so the speed here would be 200 divided by whatever that is, you know. So we can figure out these slopes. But again, this has the largest velocity, so the largest slope. This has the smallest slope, and this is in the middle. Okay? That's all there is to it. Okay, let's do this crazy one. Miles, oh my gosh, miles. We like to use metric system, you know? Miles, whatever. All right, so what's going on? What's the slope here? 0. That means the velocity is 0. No kidding. I mean, just look at the silly thing. The position is 40 miles. For 1 hour, this object stays at 40 miles. So if it stays at the same position for 1 hour, that means it's not moving. So the velocity is 0. Okay, now what's this? This is a negative slope. What does that mean? It means that the velocity is negative. Well, remember, this is positive, that's negative. So negative velocity means the object is going in a negative direction. All right? And what is the slope here? Let's just figure this out. What's the slope? So again, the slope here is the delta x in miles divided by delta t in hours. So let's go between this point and this point. Well, what's the change in, what's this? What's the rise? It goes from 40 to minus 20. So what's that? It's final minus initial. So negative 20 minus 40 is minus 60. So it's minus 60 miles, right? Minus, agree? Because it's final minus initial. The time, final 2 hours minus initial 1 hour. So 2 hours minus 1 hour is 1 hour. 1 hour. So it's minus 60 miles per hour. Minus 60, going that way. What's happening here? Slope is 0. And again, it makes sense because the position is not changing over this hour. What's the slope here? Okay, it's positive, so that means, right? So look at, nothing goes left, nothing goes right. Okay, let's see what it is. So we want from here to here. So this is final, this is initial. So what's the change in position? So 0 meters, or miles, sorry, 0 miles, that's the final, minus a minus 20, right? Agree? So it's 0 miles minus a minus 20 miles, which is minus is a plus, so it's plus 20 miles. And then the time is the easy one, right? It's just 5 minus 3 or 2 hours, 2 hours, 2 hours. So it's positive 10 miles per hour. Okay? So there you go. That's how you use those graphs. All right. Now, here's the wonderful thing. When you're describing motion, and that's all we're doing in this chapter, right? When you're describing motion, this is it. Displacement, velocity, acceleration. Now, I'm not totally giving you the complete truth because these are averages. We're going to learn the instantaneous pretty soon. But all I'm saying is, when you're describing motion, displacement, velocity, acceleration, there's nothing else. There's no, nothing down here, right? That's it. These 3 variables, that's it. Position or displacement, velocity, acceleration. Okay? And we'll talk about the instantaneous values of this in a later chapter. All right. That's a good place to quit. Thank you.